Dear students, welcome to Divya's Math Solutions. Today we are going to discuss Chapter 4 Determinants Exercise 4.2. By using properties of determinant, show that the determinant 1a square, 1b square, 1c square equal to a minus b, b minus c minus a. So the LHS value we need to show that equal to RHS we need to show, right? So first we can take the LHS. LHS is 1 1 1 a b c a square b square c square. Here we need to apply some changes, right? So what is the answer we need? A minus b, b minus c minus a. So how we will get this a minus b? Suppose I am subtracting r1 minus r2 means here what I will get? A minus b. Here I will get a square minus b square means from there also I can take a minus b, right? Next I need b minus c. That means this R2 minus R3 means I will get B minus C, right? So the first change we can apply over there. Then only one is missing, C minus A. Anyway, first we can do these two operations together. So what is the change? Applying R1 changing to R1 minus R2 and R2 changes to R2 minus R3. These two changes we are applying together over here. So this LHS equal to row 1 is changing. That means R1 minus R2. 1 minus 1 is 0. A minus B. A square minus B square. Next R2 changing to R2 minus R3. So 1 minus 1 0. B minus C. B square minus C square. Then last row is as it is only 1c c square. So next step what we can do? We can take a minus b common from the first row. B minus c is common from second row. How we are getting this? This is a square minus b square means how we can write a plus b into a minus b. B square minus c square we can write as b minus c into b plus c. So we can take b minus c common from row 2 and a minus b common from row 1. So taking a minus b from common from R1 and b minus c common from R2. This is a second change we are applying over here. So again we can write this LHS equal to taking common means that we need to write outside. So what is the common? A minus b and b minus c. So what is remaining on the first row? 0. A minus b is common 1. From a square minus b square we are taking a minus b common means what is remaining? A plus b. Second row 0 1. B square minus c square means b plus c into b minus c. B minus c is common means what is remaining? B plus c is remaining. Last row as it is only 1 c square. Correct. Next step what we need to do? So now we got a minus b and b minus c. Next we need c minus a, right? So any subtraction or something we are doing, we will get b minus c? No, right? If you are subtracting these two means this b and we will cancel. Again we will get a minus c only. Here also if you are doing means nothing we won't get. So what we can do? Next we can do the expansion. So which one we can expand? We can expanding along the column 1 because maximum number of zeros in the column only, right? So expanding along. So LHS I am writing. LHS is equal to a minus b into b minus c. Here I am doing the expansion along this column only. So this 0 into something means 0. This 0 into something means 0. Only this one is there. So that is the which element? In row 3 first element. So A31. A31 means minus 1 to the power 4 means minus 1 to the power even number means plus only, right? So plus only 1. If you are taking this, that this row and a column will go. So what is remaining? 1 a plus b, 1 b plus c is remaining. So this is expanding. Here we are applying expanding along C1. For after that every step we need to write which one, or before that we need to write, or after that we need to mention which property or which expansion we are applying, or which thing we are applying we need to mention. So A minus B into B minus C, then cross multiplication. 1 into something means 1 only. So in bracket B plus C minus, middle symbol is minus only, right? Minus A plus B. So A minus B, B minus C, B plus C, minus A minus B. Open the bracket with the minus. So this plus B minus B cancel. So what is remaining? C minus A. Our answer only, right? So we will get A minus B into B minus C into C minus A. That is equal to what? RHS. So hence proved we can write. LHS equal to RHS means what we can write? Hence proved. This is the answer. Question number 8, second one, we need to prove value of this determinant equal to this one. So here also we need A minus B, B minus C, C minus A plus B plus C. How we will get A minus B? Is C1 minus C2 means we will get A minus B, correct? Then this one, C2 minus C3 means we will get B minus C also. That is the first change we can apply over here. So LHS, so we can applying C1 changing to C1 minus C2 and C2 changes to C2 minus C3. This is the first change we are applying over here. So this LHS we can write as, LHS means left hand side, right? LHS equal to RHS, then only we can prove. So LHS means how it will change. This C1 is changing. C1 minus C2. This is C1, this is C2. 1 minus 1, 0. A minus B. A cube minus B cube. Next C2 minus C3. That means 1 minus 1, 0. B minus C. B cube minus C cube. Last column is as it is only 1C C cube equal to. So here we can see this A cube minus B cube expansion we can apply. A cube minus B cube means how we can write? A minus B into A square plus AB plus B square, correct? So B cube minus C cube means how we can write? B minus C into B square plus BC plus C square we can write. So from this column what we can take common? A minus B common. From second column we can take B minus C as common, right? So taking A minus B and B minus C common from C1 and C2 respectively. So this LHS become LHS equal to how we can write? 0. A minus B is common means 1. So A cube minus B cube expansion A minus B. So A minus B is common means what is remaining? A square plus AB plus B square. Next is C2 we are taking B minus C common. That means 0, 1. From B cube minus C cube expansion B minus C into. That means B minus C is common. That I need to write here. I will write. Remaining is B square plus BC plus C square and last column 1C C cube. If you are taking common means that we need to write outside, right? So what we need to write? A minus B into B minus C. That we need to write outside taking common means. So this LHS equal to, sorry, next change we can check if there is any, that means we got A minus B and B minus C. These two part are missing, right? So here if you are doing any subtraction or something means we are not able to get this value. That if you are not able to get means what we need to do? We can directly go for expansion. Here we can expanding along the row 1 because maximum number of zeros in the row 1, right? So this LHS equal to A minus B, B minus C. Now we are going to expanding along R1. R1 means these two we no need to consider, only the last element. Last element is in first row, third element, right? First 1, 2, 3. First row, third column, A1, 3. That means minus 1 to the power 3 plus 1 4, that means positive value only, into 1, that row and column will go. So what is remaining? 1 1 a square plus ab plus b square, here b square plus bc plus c square. Here which change we are applied over here? Expanding along R1. So now we can write the answer: a minus b into b minus, excuse me, sorry, b minus c. Next 1 means we can cross multiply it, right? So in bracket 1 into this one means b square plus bc plus c square minus 1 into this one means in bracket a square plus ab plus b square equal to a minus b into b minus c. Next we can open the bracket, b square plus bc plus c square minus a square minus ab minus b square. So plus b square minus b square cancel, only that much, right? Okay, a minus b into b minus c, this one b plus bc plus c square minus a square minus ab we can write. So this one we need c minus a again common. C minus a, how we can take it as a common, that only we are going to check. C and this one c plus a into this c square minus a square, we can write it as c plus a into c minus a, right? So a minus b into b minus c. From these two I can write c plus a into c minus a. From these two terms I can take which one is common. Here common is b, right? So I will get b into c minus a I can write. That means from these two terms again I can take which one common? C minus a is common. So a minus b into b minus c into c minus a common. So what is remaining inside? C plus a plus b. C minus a common means remaining is c plus a. C minus a common means remaining is b. So we can just rearrange a minus b into b minus c into c minus a. This c plus a plus b we can write as a plus b plus c. That means that is equal to what? RHS. Equal to RHS. Hence proved we can write. Question number 9. We need to prove that the value of this determinant equal to this one by using properties of determinants. So here we can see this is what we need: x minus y, y minus z, z minus x, like that we need, right? X minus y, how we will get? This R1 minus R2 means we will get x minus y. Y minus z means R2 minus R3 means we will get y minus z. So that is the first change we are going to apply. Applying R1 change into R1 minus R2 and R2 changes to R2 minus R3. This is the first change. So this LHS we can write as LHS equal to R1 minus R2. That means x minus y, x square minus y square, yz minus zx. Next R2 minus R3, y minus z, y square minus z square, zx minus xy, z square xy. Next we need x minus y, y minus z out, right? So here from the first row we can take x minus y common. How? From here we can take x square minus y square means x plus y into x minus y. Suppose here I am taking z is common means I will get y minus x only. But what I need? I need x minus y. So I need to take minus z as common. The same way here also we can take y minus z as common. So first we can expand that and write x minus y, y minus z, x square minus y square means x plus y into x minus y, y square minus z square means y plus z into y minus z square. From here I can take minus z as common. So what is remaining? X minus y. Here I can take minus x as common. So y minus z xy. See, now I can take x minus y common from first column, first row, and y minus z common from second row. So what we can write? Taking x minus y common from R1 and y minus z common from R2. So this LHS, this one only we are going to apply. So this LHS we can write it as, taking common means that we need to write outside. LHS equal to, so what we need to write outside? X minus y into y minus z outside. So x minus y common means what is remaining? 1 x plus y minus z. Next, y minus z is common means 1 y plus z minus x z square xy. That means two terms we got. X minus y, y minus z we got. Next, if you are applying any change, we will get z minus x or not. That only we are going to check. Z minus x. See, this R1 minus R2 means the first term becomes 0. This one, y cancel means what we will get? X minus z we will get. Here, minus z minus minus x means z minus x we will get. So, what change we need to apply over here? R1 changing to R1 minus R2. Again we can apply R1 changing to R1 minus R2. So LHS equal to x minus y, y minus z, R1 minus R2. So 1 minus 1 is 0. X plus y minus z. So minus minus cancel. What we will get? X minus z. Minus z minus minus x, that means x minus z 1 y plus z minus x z square xy. So next step we are going to take x minus z common from row 1, but instead of x minus z what I am going to take? Z minus x. Z minus x means what I can write over here? Minus 1 I can write, correct. So 1 minus is common means what we will get? Z minus x. Here also minus is common means Z minus x I will get. So next one I am going to take Z minus x as common. Next we are going to take x minus z common. X minus y, y minus z. Instead of x minus z I am taking Z minus x as common. Z minus x. Z minus x common means what I will get? 0. Z minus x is common means what is remaining? Minus 1 is remaining. Here also Z minus x common means minus 1 is remaining. 1 y plus z minus x z square xy. Correct. Next, this one 3 terms we got. Then only one more term is missing. Which one? xy plus yz plus zx is missing, right? That means we can go for expansion. Expansion means otherwise we can add this c1 and c2 means after that we can expand. That means this becomes 0. Minus. Adding means minus 2 will get subtracting, or directly we can go for expansion. Anyway, 1 0. Maximum number of zeros in row 1 or column 1. So expanding along R1 or C1 we can do. So here I am expanding along C1. Expanding along R1 I can do. Expanding along R1. So this x minus y, y minus z, z minus x, that is an outside. 0 into something means 0. Next, this is which element? A. First row, second column, A12. A12 means minus 1 to the power 3. That means minus value we will get, right? So minus minus 1. Minus minus 1. So that row and a column will go. So what is remaining? This row and column will go means 1 minus x z xy. So this is minus means next one is plus only, right? Plus the value is minus 1. That row and column will go. That means 1 y plus z square. So x minus y minus z minus x in bracket minus minus plus, then we can cross multiply. 1 into xy is xy minus x into z is minus xz, this minus 1 in bracket 1 into z square is z square minus z into y plus z. So next we can open the bracket and simplify. X minus y minus z minus x, xy minus minus plus xz. Next minus this one, first we can open the bracket inside z square minus zy minus z into z is minus z square. Next we can open the bracket equal to x minus y minus z minus x. Here plus z square minus z square cancel. So what is inside the bracket? xy plus xz minus minus plus, that means plus zy plus zy, that is the RHS, right? Equal to RHS. So hence proved we can write. Question number 10. First one we need to prove this one. So first one LHS we can take. LHS equal to this one only. X plus 4, 2x, x plus 4, 2x, x plus 4. We need to prove 5x plus 4 into 4 minus x the whole square. So with the change we can apply over here. 5x plus 4. How we will get 5x plus 4? See, if you are adding these three together, x plus x is 2x is 3x, 3x plus 2x is 5x plus 4 you will get, right? Here also 5x plus 4. If you are adding this one also you will get 5x plus 4. So this one how we can apply the change. R1 changing to R1 plus R2 plus, R1 changing to R1 plus R2 plus R3 we can apply. That is the first change we are applying. Applying R1 changing to R1 plus R2 plus R3. R1 plus R2 plus R3. So x plus R1, this is the row 1 plus row 2 plus row 3. So if you are adding means what we will get? Row 1, row 2, row 3 means adding means you will get 5x plus 4. Next here also we are adding means what we will get? 5x plus 4. Here also means 2x plus 2x, 4x plus x is 5x plus 4. 5x plus 4. Then remaining rows are same. 2x, x plus 4, 2x, x plus 4. Next step we can take 5x plus 4 is common from R1. 5x plus 4 common. So what is remaining? 1, 2x, x plus 4, 2x, x plus 4. So here we are applying the change, taking 5x plus 4 common from row 1. We are taking common from here. Next we can apply some more changes. Suppose I am subtracting these two. C1 minus C2 means I will get 0 over here, right? C2 changes to C2 minus C1, or C1 changing to C1 minus C2 means 1 minus 1 0, 2x minus 2x 0 here I will get. Here also next 1 minus 1 0, x plus 4, this one subtracting v2 on 0, only this one only. Okay, anyway we can apply. Next one 5x plus 4 means one part we got. Next one we need to get by expansion only. So we are trying to make maximum number of zeros in the rows or columns. So this one I am changing as C1 changing to C1 minus C2 and C2 changes to C2 minus C3 I am taking. C1 changing to C1 minus C2 and C2 changing to C2 minus C3. So this answer become LHS equal to 5x plus 4, C1 minus C2, 1 minus 1 is 0, 2x minus x minus 4, that means 2x minus x is x minus 4, 2x minus 2x is 0. Next C2 minus C3, so 1 minus 1 is 0, C2 minus C3, 1 minus 1 is 0, x plus 4 minus 2x, that means 4 minus x, 4 minus x. Next 2x minus x, 2x minus x is x minus 4, then C3 there is no change, 1, 2x, x plus 4. This is a change we applied over here. So next step we can see in the row, in the first row there is maximum number of zeros and this first column also maximum number of zeros. So we can expand along R1 or C1. So I am expanding along R1. Expanding along R1. Which row or column have maximum number of zeros? That using that we can do the expansion. Here I am selecting row 1. So LHS equal to 5x plus 4. 0 into something means 0. This is also 0. This is the last element. That means first row, third element. A13 means minus 1 to the power 4 means positive only. That means 1 into that row and a column will go. So what is remaining? X minus 4, 4 minus x, 0, x minus 4. Now we can do the cross multiplication. 5x plus 4 in bracket x minus 4 into x minus 4 we can write x minus 4 the whole square minus 0 into something means what we will get? 0 we will get. So 5x plus 4 into 5x plus 4 into x minus 4 the whole square, but the RHS is 4 minus x the whole square. So x minus 4 the whole square is same as which one? 4 minus x the whole square, because here I am taking one minus as common means how I can write 5x plus 4 into, from these two terms minus is common means the minus become plus, plus become minus, 4 minus x the whole square, minus square means what? Minus only, right? So I can write 5x plus 4 into 4 minus x the whole square equal to RHS. Hence proved we can write. 10th one, second part. Here we need to prove value of this determinant equal to k square into 3y plus k. So how we will get 3y plus k? If you are adding, we can check how we will add means we will get this one, y plus y is 2y, 2y plus y is 3y plus k. That means C1 plus C2 plus C3 means we will get y plus y is 2y, 2y plus y is 3y plus k. Here also 3y plus k we will get. That means which change we can apply? C1 changing to C1 plus C2 plus C3 we can write. Applying C1 changing to C1 plus C2 plus C3, or R1 changing to R1 plus R2 plus R3 also same answer we will get. Here I am applying C1 only. So this LHS we can write it as. After this change only I am writing the LHS. Before that we need to write the LHS value first. Then we can apply the change. Like that we can continue the step. So C1. So C1 plus C2 plus C3 means what we will get? 3y plus k. Here also 3y plus k. Here also adding means 3y plus k. C2 is same. Y plus k. Y plus k. So which one we can take? 3y plus k common from C1. 3y plus k common. So what is remaining? 1, 1, 1. Y, y plus k, y, 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 y plus k. Here the change apply is taking 3y plus k common from C1. This is a change we applied over here. Next we are going to we need k square. That means we are going to do the expansion only, right? Then we need to make maximum number of zeros. So how we can take maximum number of zero means here we are subtracting this one. If I am r1 minus r2 means 1 minus 1 is 0. This y minus y is 0 also we will get. So only one change is enough. R1 changing to r1 minus r2. R1 changing to r1 minus r2. Then any one more change we can apply. That means expansion become easy. This is enough. Equal to 3y plus k into r1 minus r2. That means 1 minus 1 is 0. Y minus y. So 0 minus k. Next y minus y is 0. Then 1 y plus k y 1 y y plus k. Here also if you want, here also we can apply one change. That means this one r2 minus r3 means that also we can apply over here. So expansion become more easy only. Anyway, this is also fine. So here we can do the expansion along the first row because maximum number of zeros over there. So 3y plus k expand 0 into something means 0. This is second element. That means a12. A12 means which one? Minus value it will come. Plus minus, right? So this one minus, what is the value? Minus k, minus minus k. That row and the column will go. So what is remaining? 1y plus k. So here we are applying one more change means here one more element we got 0. Then it will become very easy only. 3y plus k into minus minus plus k into cross multiplication. Y plus k minus y. So y cancel. So what is remaining? 3y plus k into k is k square. That means we can write as k square into 3y plus k. That is equal to RHS. Hence proved we can write. This is the answer.